11-5, solving rational equations. A rational equation is an equation that contains one or more rational expression, which doesn't clear it up at all if you don't remember what rational means. Rational equation contains one or more fraction. So this is an equation dealing with fractions. So if we review fractions for a second, and we're talking about 4/15 and 3/25. If we look at 15 and 25 and find our least common multiple, 15 times 1 would be 15, 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60, 15 times 5 is 75. If I look at my 25, 25 times 1, 25 times 2, and 25 times 3 is finally 75, where the least common multiple is the same. Well, in a fraction, we call that your common denominator. But there's a much simpler, faster way to find our common denominator than writing all the multiples. So I take 15 and factor it, and I take 35 and factor it down to my numbers that multiply to give you each of those. We always start by writing down my first term's factors, the 3 and the 5, and then I want to write down anything that is different. So 5 I already have, but this extra 5 I need. So I write it down. 3 times 25, again, is your 75, and that is my common denominator of those two numbers. But now, instead of just having numbers, my denominator is going to have numbers and variables. So I do the same thing that I did on that previous problem. I write down all my factors of 2x, which is 2 times the x. 4 is 2 times 2, so I have one factor of 2. I need the other factor of 2. And here I have 4x, which is actually what I ended up here, of 2x times 2 would equal 4x. So that is my common denominator. So instead of making sure I convert every single one, I can eliminate that common denominator by multiplying across by the common denominator. So I multiply 4x times the 5 over 2x, the 4x times the 3/4, and the 4x times the 9 over x. And when I do that, 4x divided by 2x gives me 2. These would cancel, and I'm just left with a 5. 4x divided by 4, the 4's cancel, and I'm left with 3x. The 4x cancels with a 4x, and I'm left with 9. 2 times 5 then is 10, plus 3x equals 9. Now these two steps here, you don't have to write down. Once you get used to it, you can probably do those in your head. So when I do it, I go 4x is divided by 2x, which leaves me with 2 times 5 is 10. 4x is divided by 4, so the 4's cancel, which leaves me with the 3x. The 4x times 9 over x, the 4x's would cancel and just leave me with 9. So as you get going, you can skip those two steps and just write down your solution. So now when I have this equation, I'm still not done because I don't know x's value, so I go and solve like we did any single equation problem. So I subtract 10 from both sides, leaves me with 3x equals 9 minus 10, which is -1. Again, get asked by itself, cancel multiplication with division, so divide both sides by 3. X equals -1, and now I have solved that problem. So another type of problem you could have would have not only a number times a variable, but in this case c minus 2 numbers added or subtracted, and the constant c. So when we have that, c minus 2 is actually one number. C would be a different number. As an example, if you put 5 in for c, 5 minus 2 is 3. 3 is not the same number as 2, so I need both those numbers of c minus 2 and c as my common denominators because they're two separate factors. And I'm going to multiply my equation all the way through by that c times c minus 2. So when I do this, I put it to the right just to make it easier. I take my 2 over c minus 2 times c minus 2 equals the 2 times the c times c minus 2 minus the 4 over c times c minus 2. The c minus 2's cancel here and leave me just with 2c. This term stays, nothing canceled because there is nothing in the denominator. The c's cancel in this term and leave me with negative 4 times c minus 2. So now I have to simplify this. So I'm going to distribute the 2c times c and the 2c times the 2, then take the negative 4, distribute it. So when I do that, the 2c equals 2c times c is 2c squared. 2c times negative 2 is negative 4c. Negative 4 times c is negative 4c. And negative 4 times negative 2 is positive 8. I have two like terms, and I can add them together. So I get 2c equals 2c squared minus 8c plus 8. I have powers of 2, single powers, and a constant, which means I want to put this in trinomial form. So I want to move over the 2c by subtracting 2c from both sides so that I can set this equation equal to 0. And then I have my trinomial of 2c squared minus 10c plus 8. Anytime I have a trinomial like that, I'm going to have to factor down to two binomials to solve. So as I look across to start solving my trinomial, I have 2, 10 is divisible by 2, and so is 8. So I can factor out the 2. So 2 times c squared gives me the 2c squared. 2 times a negative 5c gives me negative 10c. 2 times positive 4 gives me 8. And then I can worry about just factoring out my trinomial of my c squared minus 5c plus 4. When I do that, c squared would be c times c, so now I'm looking at 4, and the factors of 4 that add together to be 5 would be 4 times 1. They're both the same sign. Anytime this is positive, same sign. So I look over here, they're both negative. Minus and minus. Again, if this was a minus sign, that meant they were opposite signs. You'd look to the left to see which one would be negative or positive. And then if it's a negative, your larger number is negative. If it's a positive, your larger number is a positive. So they were the same sign, both negative, and now that is equal to 0 still. And so I now need my zeros. So what can I subtract 4 from to get 0? And that would be positive 4. What minus 1 is 0, and that's positive 1. And now I have my values of c that are a solution in the original problem. Always go back and double check in your original problem that they are solutions, because sometimes if I had factored and I ended up with a 2, c minus 2 is 0, so I would have not been able to solve this because you can't divide by 0. But since this is a 4, c minus 4 would just give me, 4 minus 2 would just give me 2, so I can solve this. If it's a 1, again, I could get a solution. So both these values are solutions to the problem. And those are your examples for this section 11-5.